Hello. We are going to talk in this lecture about trigonometric functions of any angle. So we have defined the 6 trig functions for acute angles. That means angles that are less than 90 degrees, and we've put them in what only really makes sense in our right triangle. That's kind of the definition. But now, don't you just want to really open up your world a little bit, right? We know that there are angles that are greater than 90 degrees, and we want to be able to talk about what it means to take the sine, cosine, and tangent of those angles. And we actually can. It's a very exciting, well, whatever you think is exciting, maybe not exciting to you, but it's an exciting prospect to be able to take the sine, cosine, and tangent of angles that are not just in a right triangle. We're still going to kind of, when we see that we can do this, the right triangle is still going to be involved. We're just not going to restrict ourselves to just those angles in the right triangle. You'll see it. Why don't we just move on and keep going on it? So I just want to do a couple definitions here. So what is an angle? And, if I were in class with you, I would have you describe to me what an angle is. I'm sure if I asked any of you to draw an angle, you could do that. But the technical definition of an angle, it is a union of two rays. And remember, a ray is really just a line with that starts from a point and continues on with common endpoint. Two rays with common endpoint, and we call that endpoint the vertex. Okay, so that's we can also that's what we got, right? So I have this point called a vertex, right? And so I have a ray going out here, and then I have another ray maybe going out here. And so this right here would be the angle in between those two rays. This can also, oh man, apparently I don't know how to spell today. It can also be thought of as a rotation. So what we mean by a rotation is if, well, let me define the sides here a little bit for you. So we call this side right here, this bottom side, we call this the initial side. And then if we think about this, it's like what they were saying with a rotation, is if I took this initial side and I kind of thought about rotating it through this angle, this right here is what we call the terminal side or the end side. That's going to be pretty important to know what we mean by terminal side, because I'm going to use that term kind of a lot as we go through this. And I'm going to just apologize right now for the lines that are not going to be lines. Apparently they just threw me these random little squiggly things, so sorry about that. This is my initial side. We can think of it as a rotation through that angle right here. A lot of times, of course, we call this angle theta or alpha or beta or some wonderful Greek letter that we don't really, that we're going to learn about. So a couple things about this. We say that we have a positive angle. Okay, so we describe the angle as being positive if we have a counterclockwise rotation. I assume everyone knows what clockwise and counterclockwise means. So if we have a counterclockwise rotation, so if I have my initial side, right, and I'm going to rotate counterclockwise, which would be this way, then we say that that angle is positive. We can talk about a negative angle. Negatives can be used for stuff like this. We always say like there's no such thing as a negative distance, but in like calculus and stuff, we actually can have like a negative velocity. It really just tells us the direction something is going in. So negative numbers, if you think of that on the real number line, really negative numbers just tell us what direction we want to go in, right? We're going to go left of 0. That means I'm going negative. If I go to the right of 0, it's positive. So a lot of times negatives can make sense even in situations where maybe we don't think they make sense. So if a positive angle is a counterclockwise rotation, then of course a negative angle is going to be a clockwise. So we define a negative angle to be where I have my initial side or my initial ray, and so instead of going up this way, right, which would be counterclockwise, I'm actually going to go down this way, and so I have an angle then that is negative. So this angle right here would be negative. Okay. you've probably seen some of this before. So let's talk about kind of how we graph some of these angles and what they mean. Okay, so for example, let's just talk about a couple interesting angles. Obviously a 0-degree angle, that's pretty boring, but it's important to talk about. That's just a ray that has not had any rotation at all. Some things that we know, right? We know a 90-degree angle. We're pretty familiar with those. So if I have an initial ray, and then 90 degrees is just going to make a 90-degree angle with my terminal side and my initial ray. 180 degrees then, if you think about a 180-degree angle, well, I'm going to go 90, and then I'm going to take this guy and I'm going to go another 90 degrees. So this makes sense. 180 degrees then there's my initial side. I'm going to rotate this guy all the way over, and sometimes we'll even put like a little arrow right here, especially with the 180 degrees, because 180 degrees and a negative 180 degrees are going to be the same. So it kind of makes sense that we would want to know what way that's going. That actually makes sense for all of them. If I bring another 90 degrees, we're actually going to be at 270 degrees. And so again, there's my initial side. I'm going to come all the way to 180, and then I'm going to go down here, and that's my 270 degrees. Again, with this arrow showing me the direction that I want to go. Okay, and then of course, if I add another 90 degrees, I get 360 degrees, which again is just this. So how do I indicate that this is different than 0? I'm just gonna again put that little arrow that tells me I've gone from, there's my initial side, and it's gone all the way to the terminal side, which is just going to be the same thing. We also know, some other angles. We know 30 degrees. If I was at my initial side, well, this is 90, right? It's gonna be about a third of 90, so that's not perfect, but 30 degrees is important. 45 is important. We've seen these values before. They're interesting to us because I know the sine and cosine of them. 45 degrees, and again, I'm gonna make my little arrow here, is half of 90, right? So there's my 45 degrees. 60 degrees, that would just be 2/3 of the way to 90. So I hope these all kind of makes sense. Maybe right about there. Again, not perfect, but that's okay. What if we had something like 280 degrees? So let's think about where 280 degrees would go. So if I look at this 270 degrees, I would go, and that's not a perfect 270, but this is only 10 degrees more. So if I look at 280 degrees, I'm going to think about, well, 270 would be right here, and I'm just a little bit bigger than that. So this would be that would be my 280 degrees. Okay. Some important ones, a lot of the important ones that we're going to look at are really, and we'll talk about this later with reference angles, but we're going to look a lot at like ones that are maybe 30, 60, or 45 degrees away from one of the x-axis. So like 210 degrees. So if I think of 210 degrees, here's my initial side. Well, 210 degrees, I know 180 degrees is going to be, that line right there. And then if I take 180 from 210, I'm 30 degrees more than 180. So I'm going to be right about there. So there's my angle of 210 degrees. Okay. These are really important to look at. They're important ones to know. Of course, you're going to, have homework and stuff with it. But let's talk really quick before I want to come back to that layer. Or to those angles that we just did. But before we do that, what I'd like to do first is make another definition. And this definition is going to be pretty important for us. Well, I'm saying everything in this section is important, which is not wrong. But I want to talk about something called coterminal angles. So coterminal angles bring in this whole new kind of complexity to when we talk about angle measure. So we just talked about what a positive angle is and a negative angle is. And notice I didn't do any examples with the negative angle. So we have negative angles hanging out in there. We actually have an infinite number of different angles hanging out in there with any of those angles that I drew. But let's talk coterminal angles. Coterminal angles are angles that have the same terminal side. Okay, coterminal angles are angles that have the same terminal side. Okay, so for example, if I looked at, let's go back to here. Okay, so if I look at coterminal angles, if I look at 0 degrees, oh man, I was really in my mind. I say that every lecture, trying to not do that. If you look at here, 0 and 360 degrees are coterminal angles because they're angles have the same terminal side. So what I want to look at is I want to look at these and see if I can find coterminal angles for all of these. So let's look at 90 degrees. Could I find an angle that is coterminal with 90 degrees? Well, I can. What if I decided not to go counterclockwise, but what if I decided to go from my initial side, and they don't always have to have well, let's just say they have to have the terminal side. So I'm going to start from my initial side, and instead of rotating counterclockwise, I'm actually going to rotate clockwise. I know, I'm a rebel. So I'm going to go clockwise instead, and I am going to define this angle now to be this guy. Do you see how it's basically the same angle? We still have the rays in the same side, but I've indicated with that purple arrow that I'm going the other direction. So what is my coterminal angle for this? My coterminal angle, because I'm going clockwise, it's negative. And then what have I done? I've gone this far. That was 180 degrees and then another 90 degrees. So my coterminal angle in this case is a negative 270 degrees. Same thing with 180. If I had taken this and I had gone this way, the coterminal angle with 180 would be a negative 180 degrees. Or I shouldn't say that. I should say a coterminal. With this guy, this angle, if I went the opposite direction, you see here, I'd have this here, and I'm going the opposite direction. I've gone 90 degrees. So this is a negative 90 degrees. I hope that makes sense when we're talking about these coterminal angles. Let's look at 30 degrees here. So if I had started here and come all the way around, right? Let's see what that would be. Well, look at what I am. If I hadn't stopped right there and continued on through this little part right here, I would have gone a full 360 degrees. But I didn't, right? I stopped 30 degrees short of 360. So this would be a negative 330 degrees for my coterminal angle. Same thing with 45. If I had gone all the way around and stopped 45 degrees short of 360, this would be a negative 315. Likewise with 60, the coterminal angle would be a negative 300. You guys get the idea here. 280, if we look at the coterminal angle, if I go negative, I've only gone, right? So this was 360. So let's see what the difference is between 360 and 280, because the 280, if I gone all the way around, would have been 360. So what is this angle going to be right here? Well, 360 minus 280, I think, is 80 degrees. So we get a negative 80 degrees. So I hope this kind of makes sense. Same thing with 210, right? If I look at this way, I kind of think of this as, if I went to right here, this is 90 degrees, right? And then if I go here, where am I? So this right here is 30 degrees. Okay, I was 30 degrees past 180, so this must be 60. So 60 plus 90, right? It looks like I'm at 150, a negative 150 degrees. I also could have just done 360 minus 210. I don't know why I didn't do that. Sometimes I try and make things harder than they are, which I think is kind of just a quality of a math teacher sometimes, is to just make these things harder than they are. So that's what we mean by coterminal angles, maybe when we're looking at positive versus negative. I'm going to make this a very interesting picture because now I'm going to add even more. Another way we can look at coterminal angles is, well, what if I hadn't just, let's look at this 90 degrees. Let's say I hadn't just gone 90. Let's say I want to go in the positive direction. But what if I had done this? What if I had taken that ray, I had gone around 360 degrees, and then I went to 90. That is an example of another angle that would be coterminal with 90 degrees. So I've started here. I've gone a whole 360 degrees here, and then another 90. So 360 plus 90 is 450 degrees. So again, all of these angles, the 90, the negative 270, and the 450, they all look the same. So when I said that I have an infinite number of angles for just one angle, coterminal angles, I'm not lying. I never would because I'm a math teacher. We can't lie. I could go another 360, right? I could add 720 to that. So I could be doing this as many times as I want. Or I could have even, now we're getting a little bit crazy, but what if I had gone all the way around the opposite direction here? Yeah. So there I went 360 and then another 270, and I could have gotten another coterminal angle that way. So these can be kind of fun or really frustrating, kind of up to you. They can be good or bad. Let's do one more example with these. I would like to, let's see, let me clear this up really quick. Yep, I keep doing that. Okay, so what about, let's just do a quick example. So find two positive angles and two negative angles that are coterminal. I'll just say coterminal to the given angle. All right, so let's look at the first angle. So I want to look at a negative 10 degrees. So I want to find two positive angles and two negative angles that are coterminal to negative 10 degrees. So one way you can do this, kind of the easy way, is you could just start adding 360 or subtracting 360. That's kind of the easiest way to find coterminal angles because it's really all it does. So let's kind of look at why that makes sense. So I'm going to kind of graph this angle, and I was starting to put XY coordinate system. Sometimes that's an easy way to graph angles if you're not sure where they're at, and I'm not always great at drawing the angles without graphing it. So if you could draw kind of your X and Y axis and then kind of see where your angle is going to be. So here's my initial side, right? It's always going to lie on the positive part of the X axis, and then a negative 10 degrees, I'm going to go clockwise. And I know it's probably smaller than that. That looks more like closer to 30, but just for the sake of being able to see it. So there's my angle. So let's find some coterminal angles to this angle, okay? So if I decide I want two positive angles, so what would this be right here? Well, that's 10 degrees away from 360, or if I just take 360 times plus a negative 10, right? One coterminal angle would be positive coterminal angle would be 350 degrees. And then if I wanted to find another one that is positive, really what I could do to that is I could just add another 360 degrees to it. Does that make sense? If I add another 360 degrees to it, do you see how I'm back here where I started? So if I can just add another 360 degrees, oh man, I'm gonna have to do that in my head, carry the one 710 degrees. You guys, I'm alone doing arithmetic. That's not good for anyone. 710 degrees. Yeah, that's really sad. And then I'm going to make you take some tests with a non-calculator part, and you'll be like, Sarah, why did you do that? I know, I'm sorry. Okay, so there are my two positive. If I look at my two negative, really because my angle's already negative, excuse me, I've been fighting a cold or something. Because it's already negative, really all I can do is I've already gone negative 10 in this direction. Really, I'm so sorry. Just a moment. Okay, really all I can do is go the same direction and just go another 360 degrees. Okay, so I would have a negative 370 degrees, right? And then okay, I'm gonna use my calculator again. Add another 360 to that, and we get negative 730 degrees. I hope that all makes sense. Or I could have added, I wouldn't have had to just add one 360. I could have done a negative 10 plus, 4 times a negative 360 because I want to stay the same direction. That's still going to be a coterminal angle because I'm going in that same direction. Okay, well, let's just do one more example with that. Since I have a part A, then I should have a part B, right? Or does it make sense to have a part A? What if we had 115 degrees? All right, so I'm going to kind of throw this on my X and Y plane again, and let's see what we're going to get for angle. So here is my initial side. I know that this here would be 90 degrees. I know that this is 180 degrees, right? So I know I'm just a little bit more than 90. I'm exactly 25 degrees more than 90. So I'm just going to draw this angle right here. So there's my 115 degrees. And again, if I want my two positive angles, so 115 degrees. So I'm going to go all the way around to 360, and then I'm going to add another 115. Okay, so I could do 115 plus 360. I can do that. Sarah, you can do that. That's 400. You can do that, right? 75 degrees. And then I could add another 360, or I could just for fun add, 3 times 360, so you guys could get different answers here. I'm not going to do that in my head because apparently I'm going to sing while I do this. 1,195 degrees also. What is that? 3? I went around 3 whole times, and then I did another 115. Okay, so pretty easy. I think it's pretty easy. I mean, easy seems kind of relative, right? Depending on what you're doing. Let's talk about a negative. So if I go negative, this is 180, right? The difference between, well, I could just take 360 minus 115, but I don't know why I don't ever do that. 180 minus 115. So that's 65. 65 plus 180 is 245. Yeah, which I could have done by just subtracting the 115, but I don't know why. To me, it makes sense. 180 and then another 65 degrees here. So what would I get for that? That would be a negative 245 degrees. And then again, you could take that negative 245 and add a negative 360 to it to get my other positive angle. No, I said positive. You know I didn't mean that. You know I didn't mean that, right? I meant negative angle. That looks like a triple equal, which actually we have a triple equal sign in mathematics. But that's not what I meant to do. Okay, I hope that makes sense. I think that should make sense. Holy moly, we're at 22 minutes. So this lecture is going to have to be in two parts, which will be fine. That'll be great. That'll give you a little bit of a break. Okay, other things we want to talk about when we're talking about angles. Okay, and we know this already. We've talked about this before, but let's just go ahead and put these definitions down because we're going to need them as we move on, especially when we start talking about reference angles. So the first thing I want to talk about is something we've already talked about, complementary angles. It means they say nice things to each other. Just kidding. It's kind of, if you're just having a bad day, you should give a lecture to yourself because you'll just think like, man, that was really funny. And you have no one there to confirm or deny that, really. So we know what complementary angles are, right? These are two acute angles. That sum to be 90 degrees. We know that. Right? And then the other ones, which I don't have a good joke for this one. You're like, Sarah, you didn't have a good joke for the last one. Supplementary angles are the same thing. Not the same. They're not the same thing, but they're two positive angles. So when I say acute, that should automatically imply that they're positives between 0 and 90 degrees. These are two positive angles, okay? That sum to 180. So we know those. These are pretty easy to find. Okay, so I'm not going to do any examples for those. I think you guys can probably figure out what those are, right? So what is the supplementary angle for 110 degrees? Well, it'd be 70 degrees because that's what you would add to it to get 180. What's a complementary angle to 110 degrees? There isn't one because 110 degrees isn't acute, so it wouldn't make sense. Okay, these are kind of important just because eventually we're going, well, in part 2, apparently is how long this is taking me, we're going to talk about supplementary angles and we're going to talk about something called a reference angle, and it'll be pretty important for us. So that being said, let's move on to the whole point kind of this entire section, which is this idea that now that we know what an angle is, and now that we know that angles can be bigger than 90 degrees, we know that angles don't have to always be positive, they can be negative also. What we want to talk about are trig functions I'm getting lazy. Trigonometric functions of any angle. All right, this is exciting. So what I'm going to do is I'm going to look first at an acute angle because that's where we define sine and cosine. And then I'm basically going to take that definition of sine and cosine and expand it to be for any other angle. So I'm going to take that an acute angle, okay, and I'm going to put it on the xy coordinate system. And we know if an angle so sorry, is acute, right? It's between 0 and 90 degrees. So whatever that angle is, it doesn't matter where I put it. It looks like I have decided, I'm going to try and get that a little bit straighter, to put this angle, you know, around 60 degrees, but it doesn't really matter. So here's my angle. This angle, I'm going to go ahead and get wild and we're going to call it theta. And theta is positive, so it's going in this direction. So what I want to point out, and I actually need those to be a little bit smaller. So here's my theta, here's this direction. If I took any point on the terminal side, okay, on the terminal side of my angle here, and I'm actually just going to consider, what if this point, if I rotated this point around, oh man, guys, this is where you have a lesson in imagination. Okay, if I rotated this around, do you see how, and went through any angle between 0 and 360 degrees, I'm going to get a circle. So let's go ahead and just assume that that point lies on the circle x squared plus y squared equals r. Okay, r squared, excuse me. So I know that this point on the terminal side, doesn't matter where I take it. This is the big thing, you guys. I can take that point on I can take any point along the that terminal side of my angle. It doesn't matter which one I take. Now, granted, that will change what circle I'm on, but that's okay. Doesn't matter what circle I'm on. That's a great thing when we talk about sine, cosine, and tangent, right? When we talk about these, remember how I had you guys make those triangles and everyone had different size triangles, but when we took the ratio of the sides, that ratio was always the same. This is why it doesn't matter where I take that point on the terminal side of my angle. Okay, so I took that point. I'm just going to throw it. I'm going to say it's on this circle. We'll worry more about that circle later. I actually don't even need that circle to really talk about what we're going to talk about right now, but your book defines it that way, so we'll just kind of stick with what your book does. So here's a couple things. I need a right triangle because I need to figure out how I'm going to define sine, cosine, and tangent. So I'm going to take that point right there, and I am going to draw a line straight down from that point until it hits my x-axis at a 90-degree angle, okay? And because this point lies on this circle, there's a couple things that we know. So first of all, I know this point has a point. I'm sorry. I don't know if I've had quite enough coffee today. I need a little bit more room here. This point right here, I'm going to call xy. Remember, it lies on this circle, okay? And so what do I know? If it lies on the circle, I know that the radius of the circle is r. We know that from the equation of a circle, which is x squared plus y squared equals r squared. And so what else do I know? Because I've defined this point, let's define this point to be xy. I know that, guys, look at this. I know that this distance here must be x, right? That's the definition of my x values. And this distance here must be y. Can we also just comment on what a beautiful straight line I have drawn right there? I just need to point that out, and now we'll move on. So, all right, so look at this. I've made my own right triangle, and so based on what we have here, I can actually go and define my trig values, or I can look at what my trig values would be for this angle theta. So sine of theta then, based on this triangle I have right here, remember what sine is? Sine is opposite over hypotenuse, right? So in this case, throwing this guy on the xy coordinate system, opposite is y, hypotenuse in this case is r. Same thing with cosine. Cosine of theta is going to be, well, not same thing, but you get the idea. Adjacent over hypotenuse. In this case, what is adjacent for theta? It's x, and then that's going to be over r. And then the tangent of theta, which is opposite over adjacent, is going to be y over x. you guys, this right here, I know we have the reciprocal function still. This right here is how we are going to define how to take sine, cosine, and tangent now of any angle. I am going to take sine, cosine, and tangent of any angle now, not just an angle in the first quadrant. We're going to be so bold as to put an angle in any other of the quadrants. And how will I define the sine, cosine, and tangent of that angle in any of the other quadrants? By these suckers right here. Okay, where remember, what is this? That x and that y, this is a point on the terminal side. Okay, and what is that r? I'm getting ahead of myself a little bit. That r is the distance of that point to the origin. Or if you want to think of it in the circle kind of term, it's the radius of that circle that that point would lie on if I were to take that terminal side and rotate it all the way around. Okay, so look at that. So we have these brand new definitions. Well, they're not even brand new. They're new because now theta is different. So I want you to understand that. Like, this is how we are defining to take the sine, the cosine, and the tangent of angles that are not in a right triangle. Our whole drive for sine, cosine, and tangent were ratios of the sides of a triangle. And now look at what I can do. So let's say I take an angle. And let me kind of get rid of some of this right here so we don't confuse ourselves too much. So let's look at this circle, right? What if I took an angle and I had my angle go, I don't know, let's look at in the third quadrant. So I'm going to have some angle come and be in the third quadrant. Okay, again, if I take that point that it intersects with the circle and I draw a straight line. Okay, let me make that a little lighter so we can see it. I draw a straight line from any point on my terminal side to the x-axis. Here's the thing. You always, always, always draw that point to the x-axis. Okay, when you write, you do not go to the y-axis. We always go to the x-axis. Now, notice my theta now, right? My theta looks like it's like 225 degrees, right? Something bigger than that. And so what I define again, this again is going to give me some point, we're going to do examples of this, some point x, y, right? Here's my x, here's my y. I know this is r. And so how do I define the sine of now this obtuse angle theta? How do I define it? I take, again, the y value over that r. Couple things to notice here. R is always positive, right? R is always positive. R is that positive distance from the origin to the point. It's the radius of the circle, always positive. In this case, though, like if you look at this new theta I have, what do you notice about x and y in this case? Well, we're hanging out with this point right here in the third quadrant. So actually, x is going to be negative and y is going to be negative. Oh my goodness, you guys. So what does that mean now? That means that my trig values, sine, cosine, and tangent, they now could be positive or negative. Before they were only positive, but now they could be positive or negative. I'm really excited about this. I hope you are too. Let's write this all down in one kind of theorem, and then I want to do a couple examples of this, and then I'm going to have to stop this and we're going to have to do a part 2 of this lecture. I know it's going to be hard to wait, I understand, but we have a whole nother thing to talk about, so you know. All right, so let's go ahead and write this all down nice and neat and pretty and tie a nice pretty little bow on it. All right, so trig values or trig functions of theta, where theta can be anything. So let's set this up a little bit. It's important that this makes sense to everyone, so I want us to write this down, you know, nicely and mathematically. So let's let P, and that's going to be some point with an x and a y coordinate, okay, be any point other than, well, other than the vertex, but you said any point, Sarah. Okay, other than the vertex, right? I don't want to be at the origin, then I can't make my pretty little right triangle, okay? On the terminal side, of the angle theta, shoot. So I forgot to define a couple things. I'm just going to say here in standard position. So I apologize because I got a little excited to get going. When I say standard position, I mean that the